Hello everyone, welcome to another episode of the D4 Data Channel podcast. I'm your host Deepak, and with me we have Mr. Miguel Fierro. Miguel leads the personalization team at Microsoft and was previously the CEO and and founder of Samsamia Technologies. Miguel is the maintainer of Recommenders, which is the top open source repository in recommendation systems. He has also contributed to the deep learning frameworks such as MXNet and CNTK. So today we'll hear a lot about how AI-based recommendation system and how it's actually advancing in this field. It's a pleasure to have you here today, Miguel, and thank you for accepting my invitation.
Yeah, thank you, Deepak. Happy to be here with you.
Great to hear. So I have a couple of questions, and starting with this one. So could you talk a bit about the evolution of recommendation systems?
Yeah. Well, the recommendation system is an interesting part of machine learning. The, the main idea is that it's a information filter. And what we want is kind of the evolution of search engines, right? So in a search engine, if you think about it, basically what you want is you want to get some information, right? You go to Google and you search, okay, I want to know about any topic. Now, a recommendation system is can be seen also as a search engine, but is adapted to each person specifically, right? So the idea is that a recommendation system understands the behavior of each person at the atomic level, and it allows it recommends or it predicts the behavior of the person, and you can provide solutions or items or techniques or products to these people, right? So the the key here is that it understands the behavior of people, right? And that is pretty interesting. That's pretty interesting, right? Because it is used, for example, a lot in sales. So if you think about it, in sales, one of the most important thing is you want to understand what the person wants. That's kind of the main concept of sales. When you go to a store, you have typically a person that comes to you and say, "Hi, good morning. What are you looking for?" Right? And then this person is kind of, okay, are you looking for I don't know, jeans? Are you looking for a book? Are you looking? And then this person is kind of, filtering somehow, like of all the items available that the store may have. They say, okay, so you want books, and what kind of books? Well, I'm interested in technical books, and okay, I'm interested in AI books, for example. Okay, so suddenly you went from all the uh, solution space of millions of items to something very small, right? And this is something that is being everybody has experienced that, right? Now, recommendation system allows to imitate this process in a programmatic way and at scale. So that's the key, right? Like you can do this at scale. Um, Now, initially, what happened was that um, with the growth of AI at the beginning of the 50s, people started with computer vision and NLP. Typically, this I would say that these are the biggest areas in AI, and there has been a lot of research there. And then there are some other like recommendation systems. Maybe at the in the 2000s, so there is the Belcore solution, for example, for a Netflix price that for the first time people were able to identify the preferences of movies. And I think that's when people started getting attention to these systems, right? The main problem in comparison, like recommendations in comparison with NLP or computer vision, is that recommendation is a partially observable system, right? So partially observable is that you don't you cannot access all the information in when you are doing computer vision or when you are doing NLP. So you have, let's say you have the picture of a cat, and you access all the information, right? You have the picture, you have the cat, and okay, you just need to create a system that is able to identify the cat within the context, right? Um, Whereas in recommendation system, what you're doing, the information you have is some literal interactions from the user, but these interactions, they are not directly or explicitly, in general, gives clues of the behavior or of the interest of the person, right? It's like you cannot read their mind. Like a perfect observable system would be if we could read their mind of the person, and they say, okay, yeah, like I extract that information. This is what the person wants, and we give it to her. So these systems are not as precise, I would say, as, for example, NLP and computer vision, just for this reason. And this is something that is a problem that we'll always have. So first, we started with things like the Bellcore solution that is like matrix factorization. That the idea is that you want to construct a matrix which is the behavior matrix. So basically, it's like you have in your rows you have the users, and in your columns you have the items. And basically, what you want to do is you want to give interest in each of the for each user to each item, right? And that's for example, the typical use case is for Netflix, right? So basically, all these media companies, what they do is that they take all their users and provide a score for all the movies. That's what, and basically, what you see if you go to Netflix and you see all the recommendations. Basically, this is just that you have a recommendation for all the, I don't know how many movies they have, like 5,000, 10,000 movies or shows that they have, and they are giving you the 10, the top K, the top 10, top 20 that actually have the highest score, right? That's what they're doing. And then the technology is starting to evolve. Initially, we were only taking into account user and item interactions, right? And then people start adding other kind of information, for example, item details or user details, right? And they are kind of adding that to the models. And then maybe the next iteration was around deep learning. People start doing things with LSTMs, with convolutional neural networks, and more recently, we're seeing more like attention mechanism, sequential models with transformers. There is a interesting trend right now of graphical neural networks that, particularly in recommendation systems, since it is you can pose the problem as a connectivity problem, and graphical neural networks are very powerful in that scenario. And also reinforcement learning. One of the and I'm going through more advanced to older to newer. Reinforcement learning is something that has been going on for some time, but is actually very, very difficult to implement, because if you think about it, a recommendation system is per se um, a closed loop system. So you want to create a system in real time. Whereas if you think about a lot of the solutions in NLP and computer vision, they are open loop, right? So basically, you put a prompt of text, you send it to a server, and you receive a response, right? It's kind of, whereas here is like, okay, so it's a loop. It's a constant feedback loop that the user is navigating through a web page, and is kind of moving around, clicking, maybe buying something. So you need to be able to acquire all this data in real time, put it to the model, and the model needs to update in real time. That using that's reinforcement learning, and that's pretty difficult. That's very difficult. And then maybe the last thing, which I see very interesting, is knowledge graphs. So it's not graphical networks, like knowledge graph. And the idea is that a knowledge graph is just a data set of pairs of concepts that are connected, right? And one good example is, for example, imagine if you want to recommend fashion products. If you want to recommend fashion products, what people typically do is they get in the website, they acquire all the information of the user, like the interactions, maybe the product information, user information, and they create a network, right? But a knowledge graph can encode something like fashion trends, right? So you can encode, for example, what are the trends, like what are the influencers, the models, the actresses or actors are wearing, and basically you can add this information to enrich your data set, right? And then you can have a stronger recommendations. So really interesting. I think it's evolving pretty quickly, but still there is a lot of room for improvement.
Great, great. So thank you for taking us to the entire landscape of recommendation system. So, so which is the best recommendation system available online and uh, in your opinion, basically, at this point?
There is, I mean, there are a lot of really good people there working. Obviously, I mean, I'm from Microsoft, and some of my colleagues are fantastic, for sure. So there is a team that in Xbox that they are doing a recommender that is actually in production, really strong. There is some SaaS solutions, the personalizer, for example, that is really good. It's actually a reinforcement learning real time system, really strong, used by many companies. Um, my team, we have this open source recommender solution that is Microsoft Recommenders, a repository that there you have some nice content. We collaborated a lot with Microsoft Research, so a lot of the research that we produced on Microsoft is to there. But obviously, not only Microsoft, like Netflix, for example, is fantastic. They have been pioneers in recommendation systems. Spotify, they have a really strong team. Amazon, Google, like Meta. The field is full of really interesting resources and really strong people. And I like the approach, actually, that Satya Nadella has with competition versus collaboration, right? Even though obviously, like Microsoft, Google, like Amazon, we are competitors. We are also, in many cases, we are collaborators, right? So in research, for example, we collaborate a lot. We collaborate with Google, we collaborate with Amazon. So I like this fair competition, right? Like we fairly compete as trying to create really good products that serve our customers, and at the same time we share to provide a lot of value to the community.
Right, right. So, so just out of curiosity, so out of the streaming uh, networks which we have, Netflix, Prime, Sony Live, like which one do you actually recommend? Like, how do you rank them, basically?
Um, how should I rank them? I mean, for example, I use Netflix and Disney. Uh,
What's that?
I have two kids, and Disney. I mean, like a lot. I use Disney a lot. Um, so I would say, if you compare these two, for example, I would say that Netflix is stronger. and it's probably because they have a more track record. Like they were some of the pioneers in recommendation systems, and they have more people. Probably they make bigger investments in recommendation systems, so that is reflected in the results. And if you go to Rexis, which is one of the top conferences in recommendation systems, you'll see that a lot of times they they are publishing a lot of papers. Same with, for example, with Amazon.com. Amazon, they were pioneers also in recommendation systems. There was a report done several years ago from I'm sure it was McKinsey, what basically one consultancy. They mentioned that 35% of the revenue of Amazon.com comes from recommendation systems. So like obviously they need to have a massive team of people working on recommendation system. And if you go to Amazon to a product page, you'll see the main product with the description, and below you start like every row is a recommendation system. Like you might also like similar products. People who bought this also bought that, right? So yeah, a lot of people, if you look for maybe some of our customers, ASOS in the UK, which is a top fashion company in the UK, they have that. um, so yeah, a lot of people working on that, and it's very difficult to rank them. It's very, very difficult,
Right.
but I
Correct.
think they are doing there is a very, very interesting job out there.
Right. We all actually use them, so it definitely it's very hard to
Yeah.
kind of. Yeah. And even one thing which I noticed is like it's like I really don't know because so in Sony Live network, so it's purely I bought that channel to watch wrestling matches. Okay, mainly
Mm.
WWE. So that's the main thing which I really watch in that entire network. But I never got that as a recommendation. So every Tuesday morning Indian time and Saturday morning there are like two shows, Raw and SmackDown from WWE, and every time I watch it either live or immediately after the broadcast. Okay, but I never got that as a recommendation, and instead I receive all these TV series, movies, and everything. But then I really can understand actually that recommendation is not up to par like how we have for
Yeah.
Hotstar or Netflix or Prime basically, because it's very we can understand the difference. Because if at all if that person is not interested to watch wrestling, he'll never open that uh, network. So we wish
Yeah.
okay this particular series or this particular channel to be present in Netflix or Hotstar. We really
Yeah.
wish actually. So I think even the perceptions may change from people like okay I really wanted this show to be here because I really like this platform.
So one of the things that happened is that um, the there is not a lot of maturity in the implementation of these algorithms yet in companies. So a lot of companies, for a company, if you want to do a recommendation system, the easiest thing you can do is something like the most popular recommendation, and you don't need an algorithm for that. You with a SQL query, some business rules, you can get that. So a lot of times that's what people do, and then it's like, okay, you were supposed to, so you go to a page, you think that you should have experience, like a personalized experience, and you're getting something that, I don't really care about this movie and that thing. So maybe it's because they haven't implemented that. It's not easy. It's not easy to be able to implement a recommendation system. It takes a lot of time, a lot of people. um, but again, if you do it well, I think the benchmark, I think, I really appreciate the information by Amazon.com. 35% of the revenue of Amazon.com is in the tens of billions. So I'm curious, and I don't understand very well, like, if when people hear these numbers, why not they invest more in recommendation in recommendation teams, right? Like particularly companies that they are, they have certain size. Why are not investing more? Because particularly in these times when the economy is tricky, right? And you really need to generate revenue and reduce costs. Like I don't see a lot of people really investing in this technology. And I think of all the AI solutions that you can invest in, recommendation is one, or maybe the one that can provide more revenue and more value. So maybe people start realizing how powerful this is, and maybe companies start investing more. Who knows?
Right, right. Yeah, even if the tag is not recommendation, I would say like even a part of recommendation is applied in everywhere, like even in information retrieval or ranking, or
Yeah,
like because we do a lot of in NLP, and this is what we actually witness in that output solution. So we need the top results definitely to read or understand. So that is also a recommendation. So that we can actually feel the importance of that solution.
yeah.
So coming on to the next question, like how can we maintain user privacy when collecting data for recommendation system?
Yeah, this is a very important topic. So privacy, security, um, safety. For example, in Microsoft, in particular, we have a strong group of people that their job is basically responsible AI, right? It's ethical AI. So it's like we are looking at security, we are looking at privacy. There has been a lot of content created. One of our presidents, Brad Smith, he actually is like the chief legal officer, and his main, like, a lot of his job is precisely that, right? How can we create AI that we can trust? How can we maintain the privacy of our users, the security, and at the same time, how can we be transparent of what we're doing? Now, in terms of privacy, the one of the things that everybody, or a lot of people, respect is GDPR. So, for example, GDPR in some cases um, ha- uh, doesn't allow people or companies to maintain user data more than 30 days. So there are some internal practices that companies need to enable to make that happen. Also, you need a data officer and some components. Also, some people, you as a user, you can tell the company that you don't want to use your private information for recommendations, for example. So there needs to be some mechanisms to enable that in the back end of the company, right? So you need to identify, okay, so these user, we cannot send them personalized recommendations, right? So another thing that a lot of people do is anonymizing the data, right? When you have a recommendation solution, you can anonymize the data, and then that's another way of protecting the data. And obviously the security, like you wouldn't believe like the level of seriousness that people at Microsoft take when they are creating products. So we have like exams, well, not exams, like if we want to launch a product, we need to go through a process that is driven by many people in the company to make sure that the solution is secure, and to make sure that the solution maintains privacy. So if you cannot launch a product like, hey, I have this, that's it. No, it's impossible, right? You need to go through all this process. Takes a lot of time. You need to explain how you're treating the data, and another person is like, okay, but where are you taking this data from? Where to where? Is this secure? Is this in a secure environment? So it's a very very long process, and people really take this seriously. At least in Microsoft, which is what I know. Okay, and I think there is this um, kind of thought that companies are kind of getting their data to to use improve other products. And I know that in some companies they have done that, and I think people have the right to get out of these companies. And it's very interesting because I mean, you some people might not believe me because obviously I'm from Microsoft, but it is something that we don't do here, and we don't do here because I think to me is so stupid, like so stupid. Um, First of all, I think the main reason like we don't use data from customers from we don't misuse data is because like our culture is to protect the user, protect like if you I mean if your customers if you treat bad your customers are not going to come, right? So what is the why are you going like what that's it doesn't make sense to do it, right? But the other thing that a lot of people don't know, a lot of people don't understand, is that if you know AI, particularly for people that know AI, sometimes is not people think okay, so I need to steal companies steal that data because with that data they are going to get a lot of value. That's not true. That's not true. So sometimes stealing data is really stupid because it's kind of you're hurting your reputation, and then it's not that valuable. It's not that valuable, you know. So companies or people who like groups that steal data from users, I believe is the one of the most stupid things you can do. It makes no sense. It makes no sense.
So recently, we had a discussion on not exactly related to the topic, but related to federated learning. So at
Yeah.
that time, we were actually discussing the same crucial point, like how the centralization is actually happening and how we are not actually really capturing the data point, but we are actually sending that, what to say, the information which is required to make the system better instead of capturing the real data. So yeah, actually you highlighted the similar point actually.
Yeah. Yeah.
So over to the next point. So this is one of the topic which came recently in one of the like one of my earlier podcasts for this recommendation. Like so, ideally there was something related to filter bubbles and like why or like how the user is actually getting stuck in a filter bubble and how we are actually getting the same type of recommendation even in this form of song or media whatever it is. So what actually causes this filter bubbles in recommendation and how we can mainly avoid them?
Yeah. Yeah. So basically, the one of the things that people need to understand is that algorithms are stupid, right? So if if you take a person that is kind of I don't know, like reading the news, one specific kind of news, like sport news, right? I only care about sport news, and I only care about European football. I don't care about basketball. I don't care about I don't know cricket. I don't care about football. I only care about football. Now, what is going to happen is that obviously depends. It depends on your algorithm, but most algorithms they are kind of they have this greedy approach, right? So basically it's like okay, if the algorithm has enough data, the algorithm is going to output only uh, news about football. And even you could even if 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 you don't do it right, maybe you can even have only news for your specific football team, right? Only the so that could happen. That could happen. Now, how can we avoid that? One of the things that people can do is they can add diversity and serendipity to and introduce that to the model. At the end of the day, the model is it kind of works like any other machine learning model. The data is different, but there is an optimization process and there is a loss function. So the loss function is actually you want to reduce the error between the prediction and the real and the label, right? Um, and then typically it has some regularization terms. So these regularization terms, for example, you can add their diversity, which means that, hey, if you're going to recommend 10 news or 15 news, maybe one of them add something that is slightly different to the what the typical user is. So, for example, I'm interested in football a lot. I like football, but for example, I also like tennis. So there is, if you guys have been following tennis recently, there is the U.S. Open, and it was won by a Spanish person. So Carlos Alcaraz. So the thing is, a good recommendation system will be able to understand that myself, Miguel, I like football. I particularly like Spanish football. I also like tennis, not as much as football, but the guy who won the U.S. Open was a Spanish guy. So probably I know this guy, right? So then, a good recommendation system will be able to say, okay, so I'm going to recommend two or three news of football, and then maybe the fourth one is about this guy, right? So that's how you break this silo. I think that's with like with adding these losses or these regularization terms of diversity. The other thing I think is very very important is to analyze the data. Like one of the problems I see with data scientists is that they spend a lot of time creating the model, doing hyperparameter tunings, talking about attention mechanisms and diffusion stuff, like deep learning stuff like that, and they put the model in production and they don't look at the results. I think it's very very important to look at the results, and you start looking at the data and say, okay, so this is the recommendations that I made for this user, and the user didn't click anything, or the user clicked on this one, like why, right? So, or for example, this is also super common when you are doing a recommendation solution and you are not a subject matter expert. That actually happened to me before joining Microsoft. I was the founder of a company that we created recommendation solutions for the fashion industry, and I had no idea of how the fashion industry worked. So basically, what happened is that we partner with the PMs and the experts in fashion, and we say, okay, so this is what our algorithm outputs, and basically it was a visual recommender. So we output similar visual items, right? And then I would say, I mean, like the algorithm was good, pretty good, and for me these dresses were similar, and we remember the woman's like, no, 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 no. This is a dress for the morning, and this is a dress for the night. And I was like, okay, I have no idea. Like, how do you know? And she's like, oh, it's obvious. Like yeah, because this is for the night. And I was like, okay, we're struggling a lot because there is this knowledge that for people in the area was super logical and makes a lot of sense, and for us that we were just looking at pixels and colors and textures, we were like, I don't really know how to implement that in the algorithm. So that's why it's so important to partner with the subject matter experts and look at the data, and not only get the algorithm, put it in production, and that's it.
Right, right. So same experience actually happened with me as well. Like I was really thinking about implementing something on correlation resolution and entity relation and so. But and we even recommended some solution. But at the end, whether that is actually helpful for the subject matter expert or not. So I couldn't see him checking or agreeing to the AI by clicking that bookmark icon because it's not making sense for them ideally. But in
Yeah.
the back end, we have all the fantastic stuff which we are really proud of. But ultimately, whether it's actually maybe a simple rule can actually make the difference. Okay, we need to show the link
Yeah.
one or two below or one or two above. That definitely make really sense. So I can really understand the importance of domain expertise there.
Yeah.
Obviously.
Yeah, and in fact, this is another very interesting point, which is business rules. Particularly when you have a recommender in production. Again, what I said is the AI is stupid. So typical example, and again, this happen in retail a lot. So imagine you go to a retailer and you buy a coat, right? And you buy a couple of things more, and then you bought the coat in winter, but now you're in summer, right? Now the algorithm typically is going to also recommend things rated like other coats, right? Because you bought a coat, but now, but what happens if now is summer? You don't want this algorithm to recommend something that on the winter if you're in summer, right? So that's when you can add business rules. Business rules is a very good way to add human knowledge and filter the solutions of the recommendation. The other typical business rule is when something is not in stock. Obviously, you don't want to recommend a product that is out of stock, right? So these business rules or human in the loop constraints are so important, so important, because I think a lot of people thinks that the AI is fantastic, and particularly when you have a model in production and you want to solve a business problem, right? Not is not always the best thing to rely on this AI, particularly because is not as advanced as people might think, right? Maybe in 5 years we don't need business rules, but today it is safer, and it will probably provide a better experience to your users if you have these business rules, and just kind of filter and kind of get and remove all these results that make no sense and can is obviously hurt the experience of the user.
Right, right. So in that particular regard, like there was one discussion related to the noise stuff. So like the point which you mentioned at last, like okay, why can't we just remove that stuff which we know that it's noise? But then there is a question that why AI is not actually removing the noise? Why it is not deprioritizing that particular noise? So then there is a
Yeah.
question of fight. There is a fight to the ranking for a noisy article as well as a relevant article, and there may be some words or some vectors that are really similar that will actually have that kind of conflict there, and the noisy article can go up. But in that case, if we just remove that noisy article with some very simple business rules, then definitely that problem is actually sorted. We actually face this, and it's very crucial because that point is also very valid. Why AI is not filtering noise? It's a very
Yeah.
straightforward question, but yeah, AI is good, but
Well,
yeah, we need to.
I think that's one of the main differences in from academia to companies, right? A lot of people that they are in companies doing data science, they come from academia. So in academia, you like nobody will consider to have something like business rules, right? Like you want to create a solution that is as general as possible and as powerful as possible, right? And then what happens is that a lot of these researchers, I'm one case, right? They go to the industry, and in the industry, it's like, I mean, you don't have to do research. You did research in academia. You are now in a product team, right? And I'm talking about academia, like for example, like obviously in companies like Microsoft, Google, they also have research groups. I'm talking about research versus product teams. So like the in academia, what you want to optimize for is novelty or value for the scientific community, right? In a product team, what you want to optimize is value for the customer, value for your users. And that's the mindset that a lot of people need to go through. That, and it's like, you know, sometimes you can solve the problem with a SQL query. You don't need to do distributed deep learning, like, because I've seen that a lot. Like, try to provide value, like provide as much value to the customer as you can, and that's what I call applied AI. It's basically I divide into two fields, right? Like applied AI versus research. So I think that's another interesting point of view that a lot of people miss.
Right, right. So over to the next particular point regarding the advancements in the algorithm. So like, how effective are these trainings in terms of the value they generate, basically?
So in terms of value, well, we have some metrics that are well known in the industry. One is the 35% of Amazon.com revenue. Revenue comes from the recommendations, 35%. We also have Netflix, and I think it's around 80%. So 80% of the searches in Netflix, for example, come from recommendation system. And unfortunately, like a lot of companies don't share a lot of their information. Another one that is quite famous is TikTok. TikTok, the recommendation system that they have is really really strong. And I don't know their metrics. I'd be interested to know, but you know, I've seen a lot of systems that can increase, for example, the revenue or click through rate in substantial numbers, really really good numbers.
Okay, okay, cool. So when it comes to the implementation aspect, so what are the implementation procedures that should be followed for like a large scale recommendation system?
So I think the first of all, you have the part of data acquisition that is not trivial. For that, typically you need a team of data engineers. You need to identify very well to identify the behavior and the pattern of each user, the journey of the user. And sometimes one of the problems that sometimes is that if you acquire data in the right way, your data set becomes huge. So it's suddenly it's a big data problem, right? So then you have this phase. Now the second part is the modeling, right? A lot of people, what they do is they use Spark for depending on the kind of algorithm, right? If you are doing non-deep learning, so you need to do a lot of feature engineering. So you need to hand code the features, and typically that is done in Spark as well. And then once you have that, you have two options: either go to the machine learning model in Spark, or machine learning model in a non-Spark environment like GPU CPU environment, right? But if you go, obviously, if you have Spark, you have this distributed training by default. So a lot of people, just because it's easy to have just one environment, a lot of people just use Spark environment for everything, right? And some other people, what they do is they do the data prep in Spark, and then they move that data to another CPU cluster or GPU cluster, and they start doing this retraining there. Now, if you do deep learning from scratch, then you don't have to do this handcrafted feature engineering. And what some people do is they do deep learning in Spark, but uh, this has some problems because like uh, the a lot of the code done in for the deep learning libraries it is designed for GPUs and not for Java. So then there is a loss in performance, like a really big loss in performance if you are doing distributed GPU training in Spark. But again, the good thing is that you still have one system, and that's kind of easier for teams. The other approach, and is the approach that I actually like the most, is get the data, data prep in Spark, and then move that data to a GPU cluster, and then do distributed deep learning in a GPU cluster. And then that's I've seen that. I haven't seen that done a lot, but I think that's kind of the trend. Like when teams start being more and more sophisticated, I see that trend. And the reason is because research always lead in terms of advances in algorithms, and then the industry follows, right? And there is a lag. I see a massive lag between research and the industry. And I think the best companies, what they try to do is they try to reduce this lag, and it's very difficult. It's very, very difficult. So right now it's very clear that the all the research is going through deep learning, is going through transformers in a similar way that transformers started with NLP, and then they moved to computer vision with the vision transformers. Now we're seeing that there is several algorithms. Actually, we have some of them in the recommended repository with transformers for sequential modeling, transformers. There is one reason that is pretty interesting, that it encodes the recommendation solution as text, and then send that to a normal transformer model, like one of these transformer with encoder and decoder, and just produce a recommendation to that. So there is a lot of mixture of knowledge between different areas of ML, like from NLP, from computer vision to recommendation systems.
Okay.
And then the last part. So that's the part of the training, and then the last part is operationalization. That again, the operationalization is very, very complex. If you want to have a batch system, or people use a batch system, and basically this is you compute the recommendations for a user, you store those recommendations on a data set, and then you in production you just do a query to the data set. So that's the batch recommendation. The real-time recommendation is you have the model in a, for example, in a Kubernetes cluster, and the model scores in real time. um, and obviously having this model in real time is not easy, because you need to have a request time that is not high. So some people are using either small models, or some people, if they use like deep learning models or very heavy models, they start using techniques like distillation, quantization, and all these techniques that basically helps the model to be smaller and quicker, right?
Right, right. So recently, I think like they came up with the optimum mainly, and in mainly like I think they had that Onyx format way back, but I think now it's become part of that optimization, and they came up with this optimum library, which is very helpful in a way, like, and that is one thing which I saw, and even they are quantizing all the data without losing much of a performance from the parent model. So one interesting point which I actually found out is like when you said about like the distributed. So is it because like in it's the data engineering or that data, what to say, processing part ideally, like before going into the modeling side, is it because the data which we are handling is always real time? Is that the reason why we are processing that during the, like, in the Spark cluster itself every time? Like, is that the safest way to handle that entire data?
I think it's more, my personal view is that Spark guys did an amazing job at enabling uh, people doing big data, right? Because if you if you start using a Spark cluster of any kind, in Microsoft we have Synapse. There are other providers like Databricks, for example, and that also, Microsoft will also have partnership with Databricks. Now, the magic of that is that you can have a massive data set and your model is going to work. It's basically a matter of time, and a matter of how big your cluster is, right? And the problem is if you want to do that in a distributed CPU or GPU setup, you need to build the distributed procedure, and it's very very difficult. It's very difficult. I remember that I did many years ago things related to distributed training with there is a technology called MPI. Basically, what I remember that I had to go for create a connection, SSH connection between my edge cluster and each node. So basically, I need to get the IP of each of the nodes, create an SSH connection, and then I say, okay, so this piece of data goes to this guy, this piece of data goes to this guy, and like all that process is crazy. One of the things that, and I've seen a lot of advancement in recent years in this training. One library that I think is amazing, and again, it's not because I'm from Microsoft. I honestly think this library is amazing. It's called Deep Speed. Deep Speed is a library from Microsoft Research. These are the guys that they have done Megatron Turing. Like at the beginning of this year, there was a network of NLP large language model of 500 something billion parameters. It was kind of the biggest at this point. And they have this deep learning library for distributed training that is absolutely fantastic. And it enables to kind of very easily do all the distributed training uh, reasonably free. But I think that's where the trend goes. The trend goes like there is a mismatch between the new deep learning algorithms that researchers are doing and how to enable these deep learning algorithms in the industry. And in my opinion, what people need to do, or what we need to do, is to create this spark for deep learning. Like, something that is very very simple. You don't care. Basically, it's like, I don't care if I have one cluster or if I have 10 machines. I don't care. I just want to train my model. If I have more data, I need more machines. So the experience for me as a developer, as a machine learning engineer, needs to be similar to Spark, which is fantastic. Which is, I go to my environment in Spark, I press train. It takes 1 hour or whatever time, and then you see, like, is distributing the load in all these nodes, and then I get my result. That's what I want. And I see a trend, and Nvidia, for example, they are doing an amazing job as well on distributed training on GPUs. Microsoft, again, is fantastic. This team, like, is fantastic. I know some of them, and I work with some of these guys, and I think that's the trend going forward.
So over to the next couple of aspects actually. So regarding the consequences, so like there was one statement like this where it said, so recommendations do more than just reflect consumer preferences; they actually shape them. So in this regard, there is a component of responsible AI as well. So what is your take on this statement?
Yeah, that's. That's a very interesting view. Um, I feel like all every technology have a positive side and negative side. Well, maybe not everything, but obviously many of them, right? So, I mean, nuclear fusion, you can you can create clean energy, or you can create a H bomb, a nuclear massive bomb, right? It depends on how you approach this. If if you use recommendation systems to help the user and to at the end of the day what we want to do in recommendation systems is to save time, right? So instead of going through the 10,000 movies that Netflix have, right, what I'm going to do is I'm going to 10, 20, 50, right? Netflix is giving me a good service because it's kind of filtering the results. Now, the bad thing is that if you mix recommendation systems with fake news, and you use these fake news to influence, for example, political behavior, so they vote for this specific candidate, then basically what you're doing is you are using this AI technology for hurting for the benefit of the political candidate or something, right? And it's very dangerous. I think, uh, yeah, like propaganda works. That's a fact. I think each of us as a person, we need to be aware of the sources that we look at, and we need to have critical thinking, and we need to understand that all of us are biased and that our brain can be hacked. And the thing is, you don't need AI to do propaganda. Like, they have been doing this for centuries, right? Now, but the problem is now AI systems can facilitate this fake news spread or a propaganda spread, right? So I think it's honestly very, very difficult. It is actually one of the things that I'm really worried in terms of ethical AI, and that's why I think having these policies of ethical AI is so important, because it can completely change the political scenario of a country. It can affect life. It can affect lives, right? So, like, in my opinion, the only solution is to first of all be aware that this can be dangerous, and ask people to have these protections around your data, and companies should be having this ethical AI, that and have these projects related to ethical AI to protect their customers and protect outside the world.
Right. Right. So my last question for today. What do you think the future of recommendation system look like, and where do you see all these developments and research heading to?
So I think the future of recommendation is that, first of all, is the a lot of more companies are going to start using recommendation systems. So at the end of the day, if like if you're a company, you need to provide value to your customers, right? And the best way is to provide personalized value, right? So, what is the best experience, that Microsoft can provide? I can think, for example, like, if I want to buy something, imagine if I could have Satya Nadella, CEO of Microsoft, you know, giving me information of that, or Bill Gates giving me information of that, right? That's 100 out of 100, right? Obviously, you cannot do that because Bill and Satya, they have their own things, but you can personalize the experience as much as possible, right? So that's why I think recommendation system is going to experience an incredible growth. So that's the first thing, the growth, the adoption. I think a lot of people, a lot of companies, they understand the the importance of personalizing, but they are not investing enough. So what is, I think we're going to see more and more investment, and we're going to see more and more sophisticated recommendation systems and more personalized solutions. So at the end, it's like it's going to be a win-win. Like the user is going to get a better service, and the company is going to improve the revenue, and they can reinvest more. It's like a virtuous circle, right? In terms of technical stack, I would say there needs to be teams that can work together, like data scientists or machine learning engineers plus data engineers plus uh, deployment engineers, operationalization engineers, right? Like all the MLOps cycle of the machine learning needs to be better, right? It needs to improve. And and then the third thing is closing the gap between what the researchers are doing and what the industry can provide to people, right? Um, and and the only way, in my opinion, the only way is to for products team, and this is something that I do, and I work a lot on, is be close to the researchers. Be close to the researchers. Like, hey, every now and then, I some of my colleagues is like, hey, what are you doing? Like, what's the last thing? Like, can you send me the last paper that you have done? I think that's the key, and that's how you can create a lot of value, better value, and as a company, that's how you can get ahead of the competition.
Great, great. So that covers all my question for today, Miguel. And thank you so much for being here with me today and like discussing all these important topics related to recommendation system. I personally learned a lot from this conversation. Actually, it was really inspiring to actually understand the entire stretch of how it's actually being built and how it's being deployed. So it's really great to hear from you. And thank you very much, Miguel.
Awesome. Thank you for the invitation. Thank you.